This time, I'm going to talk about Bitcoin price prediction using machine learning in Python. There are many price prediction methodologies. Roughly, we can break them down into three categories. Category 1, analytical approaches. Technical analysis is a method by analyzing historical price charts and market indicators to identify trends and patterns. Fundamental analysis examines underlying factors like financial statements and economic indicators. In this category, we also have econometric models and volatility models. Category 2, data-driven approaches. In this category, we have machine learning and AI. This is the method I'm going to use in this video. And also we have time series analysis, regression analysis, Bayesian analysis, and Monte Carlo simulation. Category 3 is hybrid and expert-based approaches. Hybrid models combine multiple methodologies for enhanced accuracy. And some people use insights and opinion from experienced individuals in the field. I know some people will follow Warren Buffett for their investment decisions. When I built my model, I used data from this website. You can go to this website and download the data. After you download the data, we can take a look. You see we have date and open price, high price, low price, close price, and volume. When we analyze our data, we can use box plot. A box plot, also known as a box and a whisker plot, is a graphical representation of the distribution of the data set. This is the output from my data. You can see this is the closing price for the Bitcoin. This is the price. You can see there is a box here, and this line represents 25 percentile, and this line represents 75 percentile, and the value I wrote it here. And you can see in the middle there is a line here. This is median Q2. That means this is the 50% percentile. And for this 25 percentile, we call it Q1. And for this 75 percentile, we call it Q3. And also there is a line here. This line is called fence line or whisker. That is calculated by calculating this IQR first. IQR is the width of Q3 minus Q1. And there is a factor K here. Usually we use 1.5. Of Of course, you can adjust that based on your needs. And then we can decide the lower fence with this formula and upper fence with this formula. Of course, in our case, the lowest fence will be negative. It doesn't make sense for the Bitcoin price. And we only use this upper fence, which draws here. You can see I wrote the value here. It's around like 26,000. And all those dots outside this fence line called the outlier. You can see we have a lot of outlier for the Bitcoin price. And then I use 3 models for this price prediction. One is logistic model. The logistic model is widely used statistical model that in its basic form uses a logistic function to model a binary dependent variables. In this model, I want to predict if the price will go up or go down for the next day. So it's binary. It's either 1 or 0. And if you use linear probability model, you will draw a line. But with logistic regression model, you will have this curve. Therefore, with this logistic regression model, we can say if this value is over 0.5, we'll say most likely y will be 1. Otherwise, y will be 0. The second model I'm using is support vector machine. SVM is a broad concept that encompasses both classification and regression tasks. SVC is a specific type of SVM used for classification tasks. It is designed to classify data points into 1 or 2 classes, making it a binary classifier. Because in this model, I want to predict if the price will go up or go down for the next day. So in this case, I'm going to use SVC. SVC aims to find a hyperplane that best separates the 2 classes while maximizing the margin. Let's take a look at this example. We have 2 classes of data points here. One class is circle, another class is square. If we draw a hyperplane here, of course, we can separate all those 2 classes. We can also draw a hyperplane here. But what we want is the optimal hyperplane. That means this optimal hyperplane will maximize the margin between 2 classes of data points. In my YouTube channel, I have another video talking about support vector machine in Python. If you haven't watched that video, you are welcome to watch that video first. The third method I'm going to use is extreme gradient boosting. Extreme gradient boosting is a simple machine learning algorithm that is widely used for classification and regression tasks. XGBoost is known for its high performance and accuracy and has been a popular choice in various machine learning competitions and real-world applications. In the future, I will make another video talking about this extreme gradient boosting. When I evaluate my model, I will use confusion matrix. In my YouTube video channel, I have a video talking about this confusion matrix for machine learning. If you haven't watched that video, you are welcome to watch that video first. Now, let's go to Python to check out our model. This is my model written in Python. I will upload this Python source code to GitHub. You can download it and try it by yourself later. First, we are going to load the data, and then we are going to check the data. And then we will draw this box plot, and then we will add more features for our data. We are going to separate the date to year, month, day, and we are going to analyze how many days the price went up and how many days the price went down. And then we will add more columns to our original data, like open price minus close price and low price minus high price, and if it's a quarter end. And we are going to use all those new features in our data analysis. And then we are going to run our model. You can see we have several models here. We have Logistic regression, SVC, and XGB classifier. And after run our model, we'll check the accuracy for the training and for the validation. And lastly, as I mentioned before, we are going to draw this confusion matrix to evaluate our model. Now, let's run the program. You can see this is our data, and if you draw the close price, it looks like this. Now let's check the data if there are any null value there. Looks like our data is fine. There's no null value. And then we can also check the distribution of open price, high price, low price, and close price you can see most of the price is clustered around here, less than 10,000. Of course, some price can go up to 70,000. Okay, let's draw a graph only for this area. You can see the price distribution look like this. Then we can use our box plot to analyze our data. You can see for the open price, so 25 percentile to 75 percentile is here, and a lot of outlier over there. Similarly, we can check high price and low price and close price. You can see the first line is here. If we check the average price of the year, you can see in 2021, Bitcoin price reached the peak. It jumped up like this, and then it went down. Similarly with the high price, low price, and close price. Okay, if you check how many days the price went up or went down, and around 54% the price goes down, and 46% the price goes up. Now, because we added a lot of new features to our data, let's check if all those features are correlated. You can see, of course, the feature will correlate to itself, and the high price, open price, low price, close price will highly correlated. For other features, they are not highly correlated. That's good. Now, let's take a look at the result of our models. For this logistic regression, you can see the training accuracy is about 0.996, and the validation accuracy is about 0.993. This is very good. For this SVC, you can see the training accuracy is 0.97, and validation accuracy is 0.96. And for this XGB classifier, the training accuracy is very high, almost 100%, and the validation accuracy is also pretty high, it's 0.98878. Now, let's take a look at our confusion matrix. 0 means price goes up. 1 means price goes down. So, you can see this is correct prediction when price goes up, and this is the correct prediction for price goes down. You can see we have much more correct predictions than wrong price predictions. This is how you can predict Bitcoin price using machine learning in Python. Please comment, like, and subscribe to my YouTube channel. Thank you.